In question 24, we have a real valued function f of x is equal to x to the nth power, where n is a positive integer, and it has neither a local maximum nor a local minimum. So which of the following must be true? So we're working with some polynomial here that doesn't have a local max or a local min. And so right away that's going to rule out something like y equals x squared, which definitely has a local minimum there, or y equals negative x squared, which would have a local maximum there. So just the fact that it has an even powered exponent, or rather that the exponent is an even number, tells us that that can't be true. Just the fact that n is even will not rule out the cases such as x squared, x to the fourth, x to the sixth. So that answer is gone. Now if n is an odd number, and again I should say that you cannot find any cases of an even power polynomial that does not have a local maximum or a local minimum. They don't exist. So they will either both start, your left end behavior will be positive infinity, your right end behavior will be positive infinity, or they will both be negative. You cannot have an even powered polynomial that does not start and end at positive infinity or negative infinity. Therefore, they both have to have a relative min or a relative max. Now the reason I say that is because with an odd powered polynomial you could have relative min or max. For example, you might have y equals x times x plus 1 times x minus 1, and it might look something like that. Well, obviously it has both a relative or a local max and a local min in there, so that wouldn't satisfy this, and that would be a third power or an odd powered polynomial. So this doesn't mean that it has to be the case for every odd power as with the even powered ones. There are no even powered polynomials that do not have local min or max. There are some odd powered polynomials that do have local min and max, but there are also some that don't. The simplest example of which is y equals x. So it is possible to have an odd powered polynomial that does not have either local min or local max. So let's go on to C. Well, if n is a multiple of 3, if it were 3, it is possible. For example, the polynomial y equals x cubed does not have local min or max. However, if we're talking about multiples of 3 though, 3 times 2 would be 6, and 6 would definitely be an even powered polynomial that would have to have a local min, at least one local min or local max. And so answer C has to go. Then D, n can be any positive integer. Well, we've just shown that y equals x squared, where n is equal to 2 or 4 or 6, does not work. There are no even powered polynomials that have no local min or max, so that's out. And so even though there are some cases, as we showed over here, of odd powered polynomials that do have local min or max, at least we can say that if there is such a polynomial that does not have a local min or max, it will have to be an odd powered polynomial, such as was the case with y equals x and y equals x cubed. So that will be it for this video then. The answer is B.